Okay, diagram shows this curve. I've got to find the exact x-coordinate of the minimum point, okay, and verify that it's equals 0 at that stage. So what I need to do is differentiate this. So dy by dx, and this is the first part, equals, that bit will give me 3e to the 3x, and then minus, differentiate e to 2x will be 2e to 2x times by that 6, so that'll be minus 12e to the 2x, and differentiate 32 gives me nothing. So for the minimum point, 3e to the 3x minus 12e to the 2x equals 0 for stationary point. I divide by 3, so that gives me e to the 3x minus 4e to the 2x equals 0. And I can factorise this, I can take out an e to the 2x, and that will just be e to the x minus 4 equals 0. So either the first one, e to the 2x equals 0, or e to the x minus 4 equals 0. Obviously that can't equal 0, and so therefore we're going to get this, e to the x equals 4. Get rid of the e to the thing, so ln it, and that will give me that x equals ln 4. That's the exact value, and then I need to show, I'll do it up here, show that we get the minimum point is 0. So y equals e to the 3x, so that'll be e to the 3 times x, which is ln 4, minus 6e to the 2 times ln 4, plus 32. So y equals, that 3 goes at the top, so that'll be e to the ln 4 cubed, minus 6e to the ln 4 squared, that square's going up there, plus 32. And so y equals, that will just be e and ln inverse operation, so that will just give me 4 cubed minus 6 times 4 squared, which is 16, plus 32, and that gives me that y is 64 minus 96 plus 32, which equals 0. So I have verified it. And now I've got to find the exact area of the region shaded. Well, it's been quite nice to me here, because it's told me what my limits are. So I've got to find my limits. It's going to go from here to this point here, and I've just worked out that that's ln 4. So it's got to go from 0 to ln 4 of that expression, e to the 3x minus 6e to 2x plus 32 with respect to x, and that's going to give me, I'm now integrating, so there's still the e to the 3x will still stay the same. If I differentiate that, that gives me 3e to 3x. I don't want that, so it's going to have to be a third, and then minus, that's going to still be e to the 2x. If I differentiate e to 2x, it gives me 2e to 2x, and I want 6, so it's going to have to be 3 there, and obviously that's going to be 32x, and that is between the values of ln 4 and 0. And I've still got to find the exact value, so I need to be careful of this bit. So it is 1/3 of e to the 3 ln 4 minus 3e to the 2 ln 4 plus 32 ln 4 minus, and now I put in 0. Put into 0, e to the 0 is 1, so that'll be a third, minus, that'll be 1, so minus 3, and if x is 0 here is 0, so plus 0 if I want that bit in there. That equals 1/3 of e to the ln 4 goes up, 3 goes up there, 4 cubed, minus 3e to the ln 4 squared, plus 32 ln 4, minus, that's going to be minus 2 and 2/3, and that gives me, that equals, e's and ln's cancel out, so that'll be a third of 64, so it's a third times by 64 minus 3 times 16 plus 32 ln 4 plus 2 and 2/3, which equals minus 24 plus 32 ln 4. Now you could just leave it like that, or you could realise that that bit there is actually the same as, so I put down or, that equals minus 24 plus 32 times by ln 2 squared, and that 2 would obviously means it could come out the front, so that equals minus 24 plus 64 ln 2. But either one would be correct to get the full credit for either one. But it's quite nice leaving it like that when it's simplified down. And that's 5 done.